formalizing Alright, a relation. That's a pairing of numbers in one set. Pairing of numbers in one set. Domain. With the numbers of another set. The range. So an example would be like x and y. And remember last week, what did we say that the x was? Good, the domain. And the y was the range. Had another name for it. Very good.
Thank you.
Input and output. Everybody got that? Alright, function. A function is a special relation in which each domain is paired with exactly one range. And that's your y's. That means each x has exactly one y. Okay? Each x has exactly one y. Write that down. Each x has exactly one y. So if I give you an ordered pair, 1, 2, 3, 4, 5, 6, and 7, 8. And I ask you to list the domain. The domain for this relation would be 1, 3, 5, and 7. The range would be good 2, 4, 6, and 8. Got it? Everybody okay with that? All right, problem 1 on the top of 287. Says identifying functions using mapping. Identify the domain and range of each function. Represent the function or the relation with a mapping diagram. So here's what a mapping diagram looks like. Your relation is negative 2.5, 0, 2.5, 4 and 6.5, 5 and 2.5. All right, your domain. If we mapped this relation, your domain. Your domain is negative 2. What else? 0, 4, and 5. Good. Your range. What's your range? Okay, when you're listing domain and range, you don't repeat. Meaning there's a 2.5 here and there's a 2.5 here, and they're both in the range. You don't write them twice. Okay? Now, here's the mapping part. When you map them, what does the 2 map to? The 0.5. Good. All right? The 2 maps to the 0.5. What does the 0 map to? What does the 4 map to? What does the 5 map to? There's your mapping diagram. Now you ask yourself, does each x have exactly one y? It does, doesn't it? Each of these domains has exactly one y. Okay? So, this is a function. Okay? Yes. Yes. And we'll do that one next. Okay? So that's how to map some data, and then that's how to determine if it's a function or not by mapping. Alright, so let's map this. Map 6, 5, 6, 5, 4, 3, 6, 4, and 5, 8.
Juniors are on their way back to class.
Domain, let's see, domain, and then range. 6, 6. I'm not going to write the 6 again. And 5. Range is 5, 3, 4, and 8. Alright, so when you map them, what does the 6 go with? 5. What does the 4 go with? 3. The 5 goes with the... And then you've got another 6, don't you? 6 goes with a 4 as well. Does each x have exactly one y? No. Doesn't this x now have two y's? Doesn't this domain have two ranges? And doesn't this one input have two outputs? Okay, that's not a function. Not a function.
Oh, I see what you're talking about. As long as the domain doesn't have two y's, the branch can have.
Yeah, when you look at this, I mean, what happened in this relation is that you put a 6 in once and a 5 came out. Okay? Then you went on down the road a little bit. You stuck a 6 in there again just to see what would happen, and a 4 came out. There's a problem there. Right? Just, that shouldn't happen. I put the same number in twice and I got two different outputs. That doesn't work. That's not a function. Okay? Just think about it that way. Yeah. All right, any questions there on the mapping part and then determining if it's a function based on the map? All right, turn the page. The next thing we're going to talk about is a vertical line test. This is another way to determine if a relation is a function. It's called the vertical line test. If any vertical line passes through one point on the graph, let's say this. If any vertical line touches the graph, oh boy. More than once. The relation is not a function. So if you've got a graph, okay, and let's say that here's your graph, and you take a vertical line. Can you guys picture a vertical line here? And you start sliding that vertical line along this graph. Will it ever touch it more than once? No, it'll never touch it more than once. So that's a function. Okay? This would be a function. So now here, all right, again, if you picture any vertical line, if you take a vertical line and you start sliding it along this graph, will it hit it more than once? Yeah. Okay, that means for one x value, you're going to have two different y's. That's not a function. All right. Now, what if oh, don't do that. Here's what I meant to do. What if this graph here looked like this? Now, can you picture a vertical line? Okay, now is this thing a function? But it only hits the graph once right here. Yeah, you gotta cover the whole graph, don't you? You gotta cover the whole graph. Because once you get to here, the vertical line is going to hit it twice. So it's not a function. Alright, you got to slide it all the way across the graph. Clear?
Clear.
Very good. Alright, and we got to talk about function notation. Bottom of page 288. You've seen functions represented as equations involving x and y, such as y equals negative 3x plus 1. Below is the same equation written using function notation. Function notation looks like this. The function of x equals negative 3x plus 1. This is f of x, is how you would read it. Okay? F of x. You call it function of x. The f of x replaces the y. Okay? And when you evaluate functions and say, you're asked to evaluate this function for x equals 2. The notation for evaluating this function when x equals 2 is now we write the function of 2 equals negative 3 times 2 plus 1. So the function of 2 is equal to negative 3 times 2 is, and negative 6 plus 1 is negative 5. So the function of 2 is equal to negative 5. And all this is telling you is what number you put into the equation where the x was. Okay? Other function notation could be g of x. Okay? H of x. Yeah, and it could be anything as your domain as well. It could be the function of m. Okay, but you would read this g of x, okay, h of x, f of m. Okay. All right. Any questions on what we've talked about today? Dan.
So if you run, you mean like input output cable on that you put two in the input, and then you calculate the output.
Correct. Correct. This is a list of what your domains are. This is your range. Yes.
So as long as you know what each letter is, then you should be good.
Yes. Yes. If you're asked to evaluate a function, evaluate the function of x equals 3x. But what they're going to say is, 4, x equals 3, 4, and 5. So you would say that the function of 3 equals 3 times 3, right? So the function of 3 equals 9. The function of 4 equals 3 times 4. So the function of 4 equals 12. Function of 5 equals 3 times 5. So the function of 5 equals 15. This is just kind of a reminder. It's a real clean notation because it tells you when I put a 5 into this function, I get a 15 out. Okay? So your domain is going to be 3, 4, and 5. And your range is going to be 9, 12, and 15. Okay? All right, page 290 today. 7 through 16.